Okay, so we've got our application deployed and we've got a microservice also deployed. We're routing traffic away from the monolith using the strangler pattern with Istio as our proxy. But now let's talk about how can we shore up the deployment process to increase the safety of our deployments. And first thing I want to do is just talk about there's a handful of different strategies that you can use with Kubernetes for deploying applications. So we're going to talk about those strategies. We're also going to talk about a open source project called Flagger that Weaveworks created that can help with increasing safety during deployments through the use of canaries and A/B testing. And then we're going to actually create a new feature in the microservice and deploy it using a canary deployment pattern in this environment that we've created. Okay, so let's review. There's 5 primary strategies available to you for making deployments inside Kubernetes: recreate, rolling, blue-green, canary, and A/B testing. So let's go through those, starting with recreate. Recreate is the most violent, the most destructive of the 5. And what this looks like when you create your deployment resource, your Kubernetes, the YAML for your deployment, you would just set the strategy type to be recreate. And by doing this, what happens is the Kubernetes controller, the deployment controller, actually, the first thing it does is removes any existing pods, at which point there's an outage, and then it creates new pods with the new change. So the benefit to recreate, you might be thinking, why would you ever do this? The benefit to recreate is it is the fastest of all 5 for doing a deployment, because you're not waiting and slowly rolling things out. You're just taking everything down and starting everything up. So this does work nice for, like, if you're doing local development, you want to make a change, this is the fastest way to apply that change. Okay, so now the default deployment is a strategy of type rolling update. And so when you do a rolling update, this works a little bit different in that rather than tearing everything down, what happens is, you see this in the picture here, the Kubernetes controller will actually provision new pods and incrementally replace old pods with those new pods. And so there's no downtime. There's a period of time where you're in a mixed state between V1 and V2. And you have some configuration options here. The max surge and max unavailable numbers. And so max surge tells you how many pods over the existing replica count. So we've got a replica count of 3. If we say a max surge of 33%, that means we can have an extra pod for the period of time while we're doing this deployment. So that means create a new pod, then take an old one down, bring a new one up, bring an old one down. And then max unavailable tells us how many pods can be in an unavailable state at any one time. And so that ultimately impacts, both of these numbers really ultimately impact the time that you wait for the deployment to complete. And so you can tune these numbers to be, to increase the safety of your deployment, but that would also increase the duration that it takes for the deployment. So these 2 options, recreate and rolling, are 2 deployment options that you have out of the box with Kubernetes. The next one I want to talk about is a blue-green deployment. Now, unfortunately, blue-green is not something that you get out of the box with Kubernetes. You can't set your deployment type to blue-green and then magic happens. But a common approach to doing blue-green is to use labels on the pods and services to accomplish the same thing. So in this case, what we can do is we can create 2 different deployments, one of one version, 1.0.5, and another deployment with another version, 1.0.6. And what would happen is when I create that new deployment, it will actually provision a whole new set of pods. And then I can do a single update to my service and point the service to that new deployment with those new pods, and then tear down the old deployment. Now, the problem, I mean, so this is a great way to go in that you're guaranteed that everything's up and healthy before it takes traffic. The challenge with this is that you end up having to write some orchestration to manage the creation of a second deployment resource and then updating the service to point to the new deployment and then tearing down the second deployment. Next one that I want to talk about is a canary deployment. And this is where we start talking about using the tool Flagger. We'll talk about the tool in a little bit more details in just a moment. But the gist of a canary deployment is that rather than routing 100% of traffic over to the new environment when you do the blue-green, you're actually only routing a small percentage of traffic over, and then gradually, and then once you've got confidence that the new environment is healthy, then you cut over the rest of the traffic. And then the final deployment strategy to talk about is A/B testing. So with A/B testing, what you're able to do is define some certain header variables or other information about the request patterns, IP addresses, whatnot, that say for this subset of users, this segment of users, I want to route them to the new version. So rather than randomly taking 10%, you're taking a specific user population and routing them to a new version of the application. What you see here is an example of how you could do A/B testing through Flagger. Again, we'll look at Flagger in a minute, but in this case, we're routing any traffic where the x-canary header includes the word insider, or if there's a cookie with canary equals to always is set to true. So either of those things will trigger a canary match, and those users would be routed away. So you can get really creative here on controlling who gets the new versions of the applications. So those are 5 deployment strategies that we have available to us. I want to go deep on the canary one and show how you can use Flagger to help implement a canary deployment. So what we're going to talk about is this tool Flagger, sitting right here in the middle. This is, again, open source tool provided by Weaveworks. And the way Flagger works is it sits in the middle of your, it's a resource that's deployed into your Kubernetes cluster. And what it does is it allows you to have, here's my primary deployment and primary service, which you already have. You accomplished this in the labs number 2 and number 3. You deployed your monolith and your microservice. You created a service for them. You then created a virtual service for that deployment. And what happens is Flagger is able to then also recognize that you have a canary deployment and a service for that. And then Flagger can orchestrate gradual changes to the Istio virtual service to route traffic over to the canary. And then here's where it gets real interesting. Flagger can also monitor the health of the canary. And if it detects an error condition, can automate the rollback to the primary deployment. So that's where Flagger sits. It's managing a primary and a canary deployment. It's adjusting the virtual service for traffic, and it's monitoring from Prometheus. Let's take a look at this picture. This will help how Flagger works in action. So you've got your service up here, and you've got 2 pods deployed for version 1. Everything's running great. Everybody's happy. Now we want to make a new deployment, V2. So what happens is Flagger creates a single pod of V2, and Flagger then configures the virtual service to only route 5% of traffic to that new service and that new deployment. Okay. And then all the while Flagger's monitoring V2 and making sure there's no errors that you've defined to be monitoring. So as long as everything's good, it then continuously increases the amount of traffic going to the new green environment up to some threshold that you specify. So in this case, we've specified that we want to do increments of 5% up to 50%. And once we hit 50%, at that point, we're confident, okay, 50% of our traffic is now hitting this new green environment, this new V2 environment. Let's call it good, and let's go ahead and just go full rollout. At that point, what Flagger does is rather than just scaling up the canary all the way to 100, what it does is it then triggers a traditional rolling deployment of the primary environment. Flagger then updates the deployment resource from V1 to V2. Traditional deployment kicks in. It updates one of the 2 pods to V2. Flagger keeps monitoring. It then updates the other one to V2. So now we've got 4 pods running, 2 canary, 2 primary, all of them running V2. And then Flagger kills the canary, says, all right, we're all good. We're back to steady state. V2 is running. So what's really cool here is all of this is managed by Flagger. All you're doing is creating a new resource in the cluster that says, I would like to go to V2. You provide some inputs on how fast you want it to go, what you want it to monitor. Flagger takes care of the rest for you. And if we were to take a look at how this looks inside of the custom resource. So Flagger, the canary, is just a custom resource. So we specify how often do we want to increase traffic. In this case, we're saying every 15 seconds. That's very aggressive. That is what we'll end up using for our lab today, just because we don't want to sit around and wait forever. But that's how often you want to step up traffic. We want to step by 10% until we get to 50%. Once we get to 50, we're going to roll back. We're saying here that our max threshold is 5 errors. If we're getting 5 errors, then we're going to trigger a rollback. And the thing that we're monitoring here is request success rate. If we get below 99% success rate, we're going to call it a failure. So what happens here is, if we take a look at this picture, Istio is routing traffic to both our primary and our canary instance. And if Flagger detects an error like it's doing here, then Flagger would initiate a rollback for us. We wouldn't have to do that. It would manage it for us. Any questions on Flagger before I kick off what we'll be doing for the lab? Okay, so for this next lab, what we'll be doing is we're creating a new feature. We're going to add a new piece of capability to the microservice, the market summary service. We want to start returning information in the appropriate currency that matches the user of the system. And so the way we're going to do this is we will detect what locale the user is in by looking at their HTTP headers. And based on the appropriate locale, we'll figure out the right currency for that locale. And then we'll hit an API to do an exchange rate conversion on the fly from US dollars to whichever currency the user is in. So we're going to add that as a feature right now. But when you add that feature, we're also going to add support for Flagger by configuring canary deployments. So this way, we'll make sure that this feature is rolled out safely. And if there's any problems, Flagger will roll it back for us. Sound good? Okay. So with that, go ahead and jump into lab number 4. I'll drop a note in the Slack channel. And if you need help, just call out.